What's going on, my dudes? This is Mr. Gardner and this is Math Time with Mr. G. Today we're going to do exponential functions. So what happens when it's growing very, very quickly? Can we measure that? So our equation is function of x is equal to a b to the power of x. So what does each one of these mean? F of x just means our finished amount. And so the way to view this is I put money in an investment. After so many days, how much money will I earn? A is our initial amount. So how much money did we start with? B is known as our constant ratio. Some textbooks might call it your growth rate. And that just means how fast is the money growing? Is money is growing at 20%? It's doubling. How fast is it growing? And then our last one, x, is time. How long has it been? And there are only two rules when it comes to using this. We cannot have a equal to 0, and that makes sense because when we go into an investment firm and we say, hey, we'd like to invest in your company and we'd like to invest $0, they're going to tell you to leave. So it has to be bigger than 0, and our growth rate has to be bigger than 1. And that also makes sense. How much is it growing by? If you just say 1, it's not growing. But if I say by 20%, then that means it's growing. So how do we graph these? Well, the first thing we want to find is our y-intercept. That is just when x is equal to 0. So we're going to plug that into our equation and then solve. And this is a good time to remind you, anything to the 0 power is 1. So now that we have our y-intercept, I'm just going to go to y equals 2. Then our growth rate is of 2, so that means up 2. But because it's exponential, it's going to go up quickly instead of in a straight line, and it's going to go down quickly. So why can't our growth rate be 1? Because this number inside the parentheses is actually a percentage. So the percentage that you see here is 210%. So if I said, hey, I want to grow by 3%, that means that I would write it in my equation as y equals 1.03. So what this equation here says, I had 2 people and they were growing by 210% each year, or pretty close to doubling each year. So if it was just 1, that means keep everything the exact same, 100%, no growth, status quo. So that's why it has to be some number other than 1. New fancy vocab word is called asymptote. And an asymptote just means how close can we get to a wall. And what I mean by that is this graph is going to be growing something like that. And then you'll notice it's slowly starting to die off. And why is that? So let's look at the extremes. So I say 6 to infinity. Well, that's just going to equal infinity. But if I say 6 to negative infinity, I don't have negative exponents, so it's going to be 1 over 6 to infinity, which is going to be 1 to infinity, and 1 divided by infinity is going to get really close to 0. But it's never going to get perfectly to 0. Even though this is a really large number, it's never going to be perfectly 0. So an asymptote is the wall in which it gets really, really, really close to, but never touches. So our asymptote now, just a quick reminder of how to find our y-intercept. I'm going to put 0 in for x, and I get 1. So what's our domain and range? So let's look at our graph. I'm going to put 0 in for x and get a y-intercept of 1, and then a growth rate of 2. So here's my graph. My asymptote, I put in infinity and it's going to go to infinity. So that's not an asymptote because eventually it might actually reach infinity. But then let's look at negative infinity. That got us to 0. So that means my domain is how far left and right. It's forever going to go left, forever going to go right. So all real numbers. And then my range is it's going to get really, really close to 0, but never touch, and get really, really close to infinity, but never touch. All right, if you guys have any questions, hit me up in the comments section. But other than that, be kind to each other, ask lots of questions, and think deeply.